This is Rges, Algebra 2, 2.2, and I'm going to be doing the graphs for your odd assignments, 1 through 11, and then 17 and 19. The range answers, which I actually do here also, are in your answer key as well. Okay, so the first one here, let's take a look. What we have here, I want to point out a few things, is we have an x squared term. Now an x squared term is going to result in a parabola, because when I plug in the range, by the way, or the domain, I'm sorry, is the real number. So I'm just picking some arbitrary numbers, but I'm going to pick 0, and I'm going to get 0, right? Because 0 squared is 0, and 0 times 0.3 is 0. Okay. If I pick 1, or a negative 1, because 1 squared is 1 times 0.3, or negative 1 squared is also 1. And then, so these two will come as a pair, these two as a pair, and these two as a pair. When you graph that, you will see that you have a parabola that goes up, keeps extending in both directions up in this kind of curvy way. So the range for the y would be values. Remember, the range would be from the top. The top, it doesn't really stop there. It just keeps going in both directions. So but we do have a bottom limit, and the bottom limit is 0, and that's what's represented right there. So number 3, we're doing every other one. The domain is non-negative integers, so we'll start with 0, because 0 is a non-negative integer, and we will have and so I can pick any positive numbers, keep going here, and I've just picked these, and when I'm calculating then the y values, they would come out that way. So as I plot these digits here, what I've got is a line that will continue to go, because I have lots more x values I could evaluate, but the minimum x value and the minimum y value is here, and that defines my range for the y. Okay, so this is a straight line. It's really a ray. It begins at 0, 3, and then continues to the right. Okay. The next one is an interesting one. We have x in the denominator, and our domain is positive real numbers. So I can pick 1. I'm only picking integers here, but notice it means, because they're real numbers, that they're not just the discrete points, but they are all the values in between. So I'm looking for the pattern. As I calculate this, notice that even though I start with 1, if it's positive real numbers, it can be as close to 0 as I can be on the positive side without actually touching. So as I'm plotting my points, I'm getting something that looks like this, and it will continue to go closer and closer and closer to the y-axis down here without ever touching it. On this side, it will continue to go closer and closer and closer to the x-axis without ever touching it. And so that's what we're trying to illustrate there. We call the 0 on the y-axis here, and the x-axis, we call them the asymptotes, meaning that your graph is going to hug it closer and closer without ever actually reaching it. Okay, so if we look now at the y values start there. It never hits the 0, but it is everything less than. It'll keep going down further and further. So that's what we have here, and that's what our graph looks like. Now for number 7, it says that my domain is an x such that it's greater than -3 and it's less than 9. And that's why I circled these, meaning the y is never going to equal that, but it's going to be real close to it, right? And it's never going to equal that, because that's what it would be if it were 9, but it's not. It's got to be less than 9, but it'll be real close to it. Okay, so notice what I've done here with my range. It's going to be, the value, if it were -3, would be 2, so it will be greater than 2. I'm sorry, not -2, +2. It'll be greater than 2, but never equal to it. It'll be less than 10, but never equal to it. So that's what I'm indicating here when I'm graphing all three of these as points on my line, but I'm graphing this one as an open circle. And this one as an open circle, meaning my line will go all the way up to it, but never touch it. Okay. For the next one, what we have is absolute value. Absolute value will always graph in this kind of V pattern. Why is that? Well, first off, let's look at my domain. My domain is between 7 and 0, including them. So I'm not going to circle these and put these in parentheses as though it were open. All of these would be points, and I graphed each one. And notice what's happening here is, remember, absolute value, which is what my original equation is, will never be a negative number. So it has to stop at 0. On this, it's going to go up to the highest value. The range of the highest would be the 4. And, of course, it has to be greater than or equal to 0. It can be 0, but never less than 0. So we're going to get this kind of a V pattern whenever you have absolute value. For number 11, anytime we have a squared value, well, not any time, but when we have this kind of expression where we have a squared value and a single x value, we're going to see a parabola. Now, on number 11, our domain is given in discrete values. That means it's only these values. It's not a range. It's not greater than or equal to that and less than or equal to that. It's just these values. So my range, that's what I said, discrete. Okay, that means just those points, nothing else. So my range will be just these values on the right-hand side, never repeating one. Okay, so we have 1, 3, 7, and 13. Plotting it, we'll get ourselves another parabola. Whoops, sorry, missed it. These are the 2 points I calculate. I never calculate the actual bottom of this. Okay, but it doesn't matter, because recall that that's really, I actually should have, in fact, let me do this rather than graphing that way. I really should have only graphed these points, recognized the pattern, and rather than having a solid line there, because they are discrete, you should really have a dashed line like that. Okay, So your answers for 13 and 15 are found in the book. For number 17, it just says, sketch a graph of a function with the given domain and range. So recall that domain has to do with the x-axis. It's going to be between 3 and 7. And my range is going to be between 1 and 10. It is going to include them. So what I do in between these, the lowest point has to be between here and here on the x, and between 1 and 10 on the y. So I could start with a point here and include it, make it a closed circle, and I could start with a point up there and then fill in almost any way you want. I could have done lots of different things. So let's look at something else for the next one. This already has a couple distinctions between this and the last one. Let's go ahead and get our axes here. Our x is between 2 and 3, but notice it will not include those, so I'll need to put open circles. Our range is going to be between 5 and 7, and again, they will have to be open circles. Now, I could start my points different. I could put an open circle there and an open circle there, and again, whoa, missed the point entirely. Something like that. I could also put one of those points in the middle and start lower and go up higher. For instance, let's take those away. I could, let's say, take my 2, 5 point and put it right in the middle of the graph, and my 3, 7 point and put it at the beginning, let's say. Well, let's see. Okay. And so then what I did here was I'm saying that any shape you have in between these boxes, between 2 and 3 on the X, between 7 and 5 on the Y, as long as my beginning point is an open circle and my ending point is an open circle, any shape I have in between is perfectly fine. So come to class with any questions you might have on that graphing.